So, how much are you like? Uh, what were the rest of? Do you have experience with Golang or previously, or you are totally blank? Right? Hey, can anyone hear me? Hello.
Oh, can you hear me?
Yeah.
Okay. My side zero knowledge.
Oh, okay. So, setup.
Mm,
Yeah, the setup.
No.
I'm gonna wait. Let me post the thing first. So hard to use. So I can have the comments if anybody commented. Trying to do. Post it to a group. Trying to do.
My test
It's overflowing.
testing. Oh yeah, there you go. Now it's working.
Yeah.
Yep. So just to answer your question, I've uh I've done the Go tour. I've made some toy programs, but I haven't really done like anything big, like
So I'm
something
gonna
actually
cover a bit of
useful.
basic first.
Mm-hmm.
Little bit of basic. I'm gonna show it. Can you guys can see me right?
Yes.
So I'm gonna use the Go playground mainly for this.
Oh, go playground. Oh.
Yeah. You don't have to follow me if you want to. I also put up a VS Code. And for VS Code, the only extension that you need for Golang is the Golang one or Go one from Microsoft. So normally I just created this project. I'm gonna start with this project. Normally we have a project path that's mapped similarly to our repository because your Golang program is also a package. So let's start with normal Golang program. Uh, right. So it's like if you're familiar with Java, it's similar to that. You have a main loop, and also the extension will manage the import for you. So similarly in Go Playground, if you click import format, run, run it. So this is your basic Go program, and by default, this is how you build Go program by default. And if you're on a Mac, you on Linux you can use LDD to check whether it is this is very important afterwards because by default a lot of the default Golang installation they have this flag on Go enabled one, which will actually you won't compile your compile binary won't be really static unless you set it to zero. This
Mm, okay.
bit of a okay, I suck. Uh, let's see, go enabled, zero, go built, or go in, go built again. Right, it's buffalo log in, like go enabled, in, in. Okay, I don't know what happened. Let's skip it for now. Oh, I
Remove.
think I found. Okay, let's go to a basic way of. I'm gonna give you guys snippets of how to write a file first.
Mhm.
So in Golang, the libraries to create a file is the OH pack. storage. So if you want to see everything here,
Okay, packages. Okay.
so I'm gonna write a few snippets. Let's put it this way. I'm gonna write a few snippets of things we're gonna do. So if you have questions, just ask me. So I'm
Okay.
gonna create a file and you write some data into the file.
Okay.
So okay, our file is not a result first, and OS create. This is to create a file locally, deleted as well. Created a file called, I'm gonna call it test. Understand why we have this error. There's a lot of things failing on me right now.
Okay.
All right. So this is how I create a file. OS create. You see there is actually two values. One is the file and one is the error. So do not ignore your error because if you make your life really miserable. So if let's say I do this,
Mm-hmm.
if I ignore this, this is a way to ignore a certain variable in Golang. If I
Yeah.
ignore this, because let's say due to some circumstances you fail to create any file, and when you try to access it afterwards, you give you a null pointer exception. So and your program will fail anyway. But it give because you didn't handle it properly previously, it you have no idea and you might need to like guess where the error originally came from. So always check your error.
Yeah.
It looks very ugly, especially for people that came for other languages. It's fine to
Mm.
do this. Um, for the panic functions, is actually I don't actually recommend you to use in other functions. So only that in the main loop that I mean, this is my personal opinion. In the rest of the program, like other functions that you have, try not to do a fatal, raise a fatal error or a
Mm.
panic. Handle them nicely, print them out, give them a default value or something to, but manage them. But on the main loop, it's actually okay to panic or raise a fatal exception. No, there's no exception. Or yeah, or kill the program. Because if you do this in the rest of the program, you will actually kill your own program, and you have to find out like go through everything to find out where what is going on where. So
Oh, I have a question there.
yeah, go on.
Oh, let's say if you have three functions inside, you have panic, it doesn't propagate to the previous one.
You mean yeah, it will actually,
Uh,
but you don't want so many because you don't want to so many functions to
Throwing
throw it
exception.
throw exceptions and
Okay.
the way to handle exception in Golang is actually pretty dirty, like recover, and it's actually very, in a way, it's very hackish. There are
Mm-hmm.
actually better way to handle your exceptions.
Okay.
So yep, it's just a matter of getting familiar with the paradigm under Golang.
Okay.
So and exception itself is actually an interface, so that
Mm.
you can if you want you can because as the thing about interface is as long as you are compliant to the look and feel, you on Golang is automatically compliant to the interface. So
Okay.
you can have your values that comply to the error interface to wrap more information if you want to.
Is there a reason why the designers of Go decided to go this way?
um no, I have no idea, but it's actually for me the benefit of this is when you have similar to I don't want to compare it. It's when you do something like a Go routine or channel, is actually more manageable if you handle your errors, and your errors is actually a value instead of an exception.
Yeah,
So
because it looks like it's a return value, right?
yeah, it's a return value.
And so it's nothing special. It's just another value that's
Yeah,
being
just another
returned.
way. Yep.
So that means if it's just another value, then it can return any kind of type, right? As long as it fulfills the
Yeah,
interface.
as long, yep. So errors, errors interface, Golang errors, error interface, interface, error interface. Just when I need it, it's not there. Where is the example? Supposed to be the error is actually just this, the interface is only this. So as long as you have, let's say, just as the same as this example, you have a strut. As long as you have a method,
Called error.
yeah, called error, you can actually pass it as normal error.
But what prevents like me from returning like something like I can return a status code like Unix systems, right? Like not a number,
Yep,
or I can return anything like a huge paragraph,
yep.
or I can return JSON, or I can even return binary. So what's preventing me from doing all sorts of things as my return error?
Um, by it's actually a type on itself.
Uh huh.
So normally the implementation is, let me show you here. Create error is a type.
I
So
see.
so that's one of the convention that we use to
So it's really just
just a
like convention mostly. There's nothing really saying I should do it this way.
yeah, no.
Like I should
So
return an error this way, for example.
if you manage, I mean, it's a very opinionated, uh, but if you can manage your error nicely, you can choose not to return an error.
Okay.
Depending on your use cases, because some people they prefer to have a default value instead of a null pointer of this and with a error value. So it depends on your preference.
Uh,
So and your your errors, like, because it's an interface, so you can use it to encapsulate any data that you want. You can have it like uh, however you are going to manage it.
okay.
So this is, let's go back here. This is how we create a file. This is a conventions. Uh, uh, defer is actually something that runs after the, the block finishes. So if in this case the in this case the function block, when the function block finishes, it will actually run this. So I'm gonna give you some example for those that are not familiar with defer. And it goes by last in first out. So let's say I have to defer. I should have just copy and paste it. Inline hello first first second.
Hello first, hello second.
So the second will actually
Okay, interesting.
so the second will run first. It's last
Mm.
the last statement will run first, and it only executes after the program finishes. So I can have, let's say, hello world, yeah, and it's actually executed when when the function exit.
Interesting. Is it
So
like a hooks?
yeah, this is a way we use to do cleanup most of the time. Like
Mm.
when you do a database closing, but be careful because if you have a function that, let's say, connect to the database, there are something that connect to the database. Just example, if you defer DB close here, you close the you close it, so you need to be really sure that where do you want it to be closed. So you don't want it because this function is supposed to give you the DB connection. You're not supposed to run this because after this returns, it will close the connection. So be careful about that. So writing to a file is actually very simple. The first one is bytes. Bytes.
Sorry, on because you were talking about defer. Is this similar to the C, or was it C plus plus pattern where it says resource acquisition is initialization? So it's like it's a similar way of cleaning up after yourself.
You can unlike that, it's not a destructor like kind of a system. You need to do it
Ah,
centrally, but you can use it to do something similar.
okay, okay, got it.
Yeah. So this is how. And the very good thing about like one of the also the convention is since I'm at it, um, when a file it returns a file, but a file what you get here is actually I'm not sure where should because it's something that I'm basically I'm testing out what I'm familiar with as well because a file here is actually an IO writer, so it's also an interface. So where do I go from here? See the kind of you see the kind of method it has or states. If you have editor support, then you actually show you this. So file write. This is how you write. Simple, some simple value to it. So how much they are written, and I ignore this and error. And why does it come up? You see also the break underline means that this is or the error is actually declared previously. So going back to basic, declaration of a variable via copy is this way. It does the type inference for you as well. So decorate. Let me go back. Really go back. Um, so I'm gonna have a message string. This is the most primitive way to declare an empty um, variable with the type. So if I want to assign a value to it, okay, you can also use message. Notice the colon means that it's a new variable. And if you declare a new variable this way, the compiler will try to defer the type for you. So if you are just going to overwrite it, you can just move up. But one thing that everybody needs to be really careful about the type inference is especially when you deal with integer because under Golang, every types are actually not compatible. So let's say I have int I have I0 1. I have x, which is x in 64 equal to I plus x. It wouldn't work because they are considered different type. So unlike some languages that allows you to mix and match, even C, like you can mix and match different integer value and floating points. Each um, type itself is actually unique under Golang. So you need to be really careful because by default, the inference will assume that your integer is just a normal integer. So if you need it to be in 64, you need to purposely you have to set it specifically. So once, but you can always choose to custom to be the same as well. In 64, this is how I convert them. It's okay to convert upwards because that's not noisy. So let's go back here. Error. Do not ignore the error. So let's say, and this is a simple program to write a hello world into the file. So let's run it and look at it. It's written there. So this is as simple as you can see. But however, the very powerful thing about Golang is the interface because the file itself it is compliant to most of the time it's a convention, but for most of the stuff from the standard library, file that you open for read, normally they implement IO reader. So let me go this IO package is the one that specified what sort of interface they have. So normally, file that you open for reading, they implement reader. That's on it is. And the file that you open for writing, they normally implement writer. So let's have a look at the file as well. So file actually implements a reader, you can see here, and a writer. So anything that deals with I like the reader or writer can benefit from this as well. So let's change it a bit using the format. So f print. So what this contains is f print. So look, you can see here f print actually takes two parameter, not two, more than two. Takes a writer and writes a bunch of stuff to it. So I can replace this to the file instead and hello world. So you'll be still the same. And let's have a look at the text file. The IO part is actually very important because afterwards, this is how we are going to benefit from writing our web server as well. So, what else? Yep, this is just a simple way of writing a file. So let's write something more. So let's write some. Let's create a file with some variables, and we're gonna read it. So, okay. Let's do it simple. Let's write a few lines. Let's write 50 lines. There are better way to do it, but just as simplicity. New line here as well. Run it. So cat. So now I have 10 lines of this, 50 lines of this. Let's add in a bit of differences. if you have a format string, you add in this. Fine. So this is the program to write 50 lines. Then we want to write another program. Let's put this aside first. This is called the file. I call it writer. Put it in there. So let's create a file to, because we have this, we're gonna go to the reader. So go. So the same file error. Instead of create, we have opened. So it's very verbose, very repetitive for this, but it's unfortunately you have to get used to it. So write it. Okay, I have some reading is not so straightforward. How do I show the most basic one first? It's, I'm gonna just read. I'm gonna read some. Right. I'm gonna read 10 bytes. Mm.
I always like to think of make as something like new or something like when in C or C++ you malloc like allocate like some memory for the array.
This is how you do allocations.
Yeah,
But I'll have to cover the part about slice as well afterwards. So let's.
I'm not sure, Manju, if you've gone through the different types of like I guess things. Like there are value types and there are like these types of memories, memory specific what allocations.
No, not really. Only in the university.
So I'm gonna cover that afterwards. So this is the one that normally people. I mean, the if you really want all the control, you write, you read the file, you open the file, then you read how much that you want until you get nothing, of course, from here. Uh, so this is actually a way, traditionally, how you read by your buffer size. So right now, I just read just 10 bytes of it, so which is just enough for hello world. And normally, when people get started, they like to use IOUtil. I'm gonna show you guys library. IOUtils actually provide you the helper to do this to easily read, let's say, file. Instead of this, I have B data IOUtil it. I forgot the name again. Read file s.txt. This is the part, one of my favorite part to show. So line and Go's compiler actually optimizes the casting between bytes and string. But be careful because byte and string are different because string itself is actually UTF-8. So this is how normally when people start, when they want to read everything. So basically what you does here is you have a helper, IOUtil, to read everything in, like everything of a file. into the buffer. But but the thing about this is this will load the whole file into the memory, which actually I don't like,
Yeah,
and
yeah,
and which is why that uh for small file it's actually good. Like also in this case, if you notice, you have to do the if you want to separate each line, you have to do the separator yourself, right? So let's say b say so strings split that's written by new line manually. Then I actually have what do you call it messages. So I can print how many messages do we have? Okay, do you have to do the splitting manually, and you see it is not splitted nicely as well. So it's good enough to start, but I don't recommend this method. I'm gonna show you a method that you use that for a while. So one very useful instead of IOUQ, one very useful library is called buff.io, which stands for buffer IO. And buffer IO is actually your friend. You should actually spend some time to read through some of the stuff you can do with it. And a lot of time it deals with IO. And one of the things about, especially when you deal with file incrementally, is the scanner. So for here, I'm going to throw this away. I'm going to have a scanner, IO, new scanner. And scanner actually accepts a reader. So for scanner and for the separator, you can actually customize it yourself afterwards. So the token is by default, it actually separate by new lines. So you can actually override whatever separator you prefer. Or if you really want things to be really manual, you can also use the method just now by pre-allocating using a buffer to gradually read through all of them. So scan, and I have a line by line. So scanner, and this is a much better way to I read, I basically read through everything. And the good thing about this is it keeps the file header in check, like basically similar to what we do with manual buffer, but in a more economic ways. Like I basically get line by line without loading everything into the memory. So buff.io is very useful. And this is for file. And oh, I'm gonna stop. I'm gonna conclude this part. It's a bit. I'm a bit all around the place right now, so feel free to interrupt me. Also,
These are all built-in libraries,
yeah,
right?
these are built-in
You
libraries.
did you never had to install third-party libraries here.
And yep, and this part, especially buff.io, is very powerful. So try to use them often, and you can do a lot of minor optimization. That's especially this like you uh. But I think it's a paradigm nowadays that when we read the file, we even like it happens to Python as well. We don't read everything. Instead, the reader actually creates a generator. When you read, then it only goes to the position of the file instead of loading everything just one shot into the memory.
Mm.
So this method is actually more memory efficient. And
So,
yep,
so
yeah,
all the buff.io methods
yep,
function similarly.
yep. So most of the things that allows you to write stuff, they implement writer. Most of the stuff that allows you to read stuff, they implement readers. So what are the stuff that implement writers like HTTP response? So HTTP response itself implements a writer. So whatever we did here can be done on HTTP server as well. So let me do a bit of a simple demonstration of this. Let me fork this code. similar. Oh, I got it. The name again. Easy. So instead of this, I'm gonna be really bad. I'm gonna just have a HTTP server is also and client also is it's also packaged in the Golang standard library as well. So handle so the path function. It's basically the library that you need to for reference is net HTTP. The documentation itself is also a tutorial, so it includes things like this. There is always they always provide you the high level client or similar to like just now the IO util higher level functions, but the powerful ones are the lower level one, and they are not so hard to use comparable. So this is how I'm gonna have handle the routes. And Golang supports first class functions. So here I'm gonna have a server, VP, listen and serve. It do a panic. So instead of this, I'm doing something that you guys shouldn't do in production. I'm gonna read a file every time I call this, but I'm gonna add in some delay time state. Actually forgot what's the parameter. And I'm gonna wait a second. Wait a second. And instead of this, I it to depends on my way to do it. I can do this. W because the response is actually a writer. So I can write it directly back to here. Let's start the server. It won't run nicely because it's AT. So here, see, I'm actually slowly writing it to the response. And do check out some of the function in IO and path IO. Also, if you just are going to pass through certain data, you have actually the copy function, which direct. If you don't want to handle this file directly, I can just pipe it to the response like this. Here, what's the destination and source? Destination is the response writer, as we can see from here, and original is here. I didn't handle the error. So the very powerful thing is the standard library, especially on the IO part, is actually very powerful. Oh, okay. The folks are complaining that my volume is too low. Are you guys hearing me okay?
Yeah, I'm good. It's clear for me.
It's all good for me too.
So the IO part is really powerful. So and also it's not just available in because a lot of stuff is actually implemented by the standard library, even the JSON one, even some of the encoding. They take in so they take in if you notice writer and reader and decoder. So and depends on how you implement them because also IO writer the writer and reader are interface. you can have your own way of implementation. Like let's say I want to have something like a rate limited way to keep data certain ways like that. It depends how magical you want it to be, as creative as you want.
But do they have streams? Data?
This is
Rate?
actually stream. This is
Oh,
but in a more, I consider
mm.
basically you uh it's actually stream, but you are the one that decide how to do the streaming.
Yeah, yeah.
But the method is already there, as long as they are complied to the writer and reader interface.
Yeah, correct. Because in Node.js, there's a such library stream. It's like a duplex. You can do input reader, writer.
Yeah,
On then during that time, you can also do transformation if you
yeah,
want to.
yeah. You can actually in the middle.
Yeah, yeah.
So so I can have I'm a bit lazy right now to implement to do it,
Yeah,
but
it's
I can
okay.
distribute it to no, I can, let's try to do it then. So we're gonna use the buff IO. I'm a bit rusty in this. Okay, so let's try it out. I have a buffer. Where bit rusty. What buff? The buffer. Oh no, it's bytes. Okay, let's implement something. So I can have a buffer of, let's say I call it I, for one for I just give it full. I don't know what to call. So buff. I have a buff bytes. So I actually implemented, let's say, write and read. So I have two. So that I actually int buff buff write. Basically, I'm just gonna write directly to it. I think it's simple. Then reader. I'm probably doing it wrong. Try it out. Wait. At least I have this implemented. So when I write, let's say I want to replace all the E into A. So I'm gonna do a very lazy replace, right? Replace okay. Old byte, new byte. Next, which is D. Old byte is, I'm gonna replace all the E, A, and let's try to do it. Instead of this, I'm gonna copy it to my buffer. I'm gonna put it full. Full buff byte, new buffer. it to full, and we're gonna copy make file to full. Copy the file to from full. Also handle error also. If error, it just doesn't matter. It's a demo here. I did clean up the codes because it's a habit. Let's try if it works. Try if it works. This work. So now I have something that replace all the E to A as a simple example by having my own like implementation of a reader or writer. So this part can be your middleman as well. So in the case of if you want to do a man in the middle reinjection of data and stuff, you
Yep.
have to implement something like interface. But as long as it's in the same interface, you can like chain it however you want it, however you feel comfortable with. Is this what you're looking for, Anju?
Yep. Yep. Transformation. Yeah. Kind of.
In a way, it's not as magical or sugary as that what you thought,
Yeah. Yeah.
because Golang itself, the implementation of interface is unlike some other languages. You don't have to type in the statement of for this implement that. As long as it is compliant, it processes that method,
Mhm.
the same function that support that interface will work.
Interesting.
And you can do some rate limit here as well, like if you want certain things, like I want it to be slower.
Mhm.
So let's say 2 seconds. So depends on where you want it to be, but I don't recommend you doing this.
Mhm.
And this is what I use for doing a lot of the packet checking and stuff as well. So in some cases, like when we especially in a HTTP traffic, you want to like check certain packets, or you want to, if you want to be smart, you can do some compression in between as well, special compression.
Nice.
And also this, since we are covering interface, I'm gonna go, before we go back to the basic, I'm gonna show you a few more examples. This is the call I call it. If you want to play with around, there is also pipe and key.
Pipe.
So they are pipes. Pipes is like basically what I did just now, but without having to without having to run this. So it's like your shell pipe. You just go through here to here.
Mhm.
It's a bit, if I'm gonna show you now, also I'm because I don't use it that often, so if I'm gonna show you now, it can be a bit confusing as well. Uh, so try it out yourself. If you want to do something like I want to have a copy, but like let's say I want to have a copy to go back to the HTTP response, then
Mhm.
but I need a copy for myself as well. So for that you have T as well, just like your command line. You have a T reader and you have a T. So that's what you do is you basically get one copy of yourself with when you do the IO reading and writing. So it become like transparent. You can actually transparently snapshot the copy without having to interfere directly with the whatever data that you're doing with. So like talk about use cases, the very naive implementation that we have for the T use cases. When you want to take a snapshot of the response, you normally allocate the the memory to read it into your to assign it to your variable, or allocate the chunk of memory, then you put it somewhere else, right? Then you return like put this into the database, and also please write this again to not again, please write this to the response. But this is one of the helper to help you to not help to help you. It's actually to make your workflow more seamless, and one of the ergonomics of doing I/O in Golang. And I can say the the most entertaining part of and also the most fun part of writing Golang is playing around with the I/O interface.
Mm.
So I'm gonna put it back here. So almost most of the stuff I've been keep repeating myself. Also almost everything that the standard library support, they take it in a way, they take in a certain interface. So handler is also an interface. So as long as your object supports this function, it can be like a handler is like your base web server, and you can do daisy chain with this. So I'm gonna go a bit to this before we go back to the basic a bit and wrap it up. So your default server by itself, take this. I'm going to introduce a few first. By itself, I'm going to do just an explanation by myself. Uh, by itself, you have a global state. This is the global handler and stuff. Basically, whatever you put in here will be served by the default, which is also the global HTTP server. So writer string error. If you notice, it accepts a handler. So right now, because we are using the default one, we don't have to specify any handler. This is how you start a web server. So start it. Hello. So this is a lot of time good enough, but sometimes we want to have application like self-encapsulate application, and probably we have different routers. So by default, it comes with a router. It's called new surfmax. So you can do this similar. Why is this so important is that you can actually chain them together. So you actually can write, you can create a middleware kind of HTTP server system without having to rely on like in some languages you need a middleware implementation. You don't need to, because of the how interface works here. So go like this. So instead of this, because Mux actually uses Mux actually implements Surf HTTP, works the same as well. Go. So what's the purpose of this is, let me write you a simple application. Okay, I'm going to wrap this, let's say app. I'm going to keep it, I'm going to call it Mux as well. I can have a handler, let's say any handler, but I'm actually accepting a pointer right now, but I can actually accept a handler as well. So I implement a basic a GP. So yeah, I actually implement a simple API server. So I'm gonna read from the header. Hit API get key if key equal okay. Let's say I'm gonna call my key as Manju, and I'm gonna have max a max, and I serve my HTTP normally. This is like a simple demonstration of a middleware. Or else, also remember to return. Or else, I'm gonna return. I'm gonna use this error. HTTP status X T forbid status forbidden. Okay. So now I have an app. So previously we have a hello world. This is like this can be your application logic or your reverse proxy or whatever.
Mhm.
But I have a not I call it app, but it's actually an API gateway. If you can see here, a simple API gateway. So I call it a gateway. So max equal to max. So because my gateway
Mhm.
implements serve HTTP, so it can be used.
Oh, this is how we implement middleware.
Yeah, this is
Mm.
very simple, right?
Yeah.
So let's do a test. Start the server. So of course, do a curl HTTP forbidden.
Mm.
But if I supply a header, remember
Yeah.
the header.
Yeah. Yeah.
Okay, Manju. Oh,
Oh, awesome. Nice.
it's very simple, and this is stuff that something that I use often a lot. Like
Mhm.
also not just here. Like you can do. Let's say I have I'm not gonna write this. Let's say I have max one. I have not max one. I'm gonna have let's say I'm gonna have a upstream one,
Mm.
or I can have a bunch of HTTP handler as let's say uh, this is my upstream, like my proxies. I can do a like a round robin kind of easily do a round robin kind of like load balancing. So it's very easy to write them in Golang. So let's do a let's since we're at it, let's do a bit of that. So let's say I have two. Uh, so I'm gonna create one. There is a better way to do it, but for simplicity, I'm gonna show you this way. Some might argue that why am I doing this when I can wrap my function into directly into a handler interface?
Mhm.
But I'm gonna skip that first for clarity. So this hello world. I'm gonna just copy and paste. Why don't I do that? So hello world. Let's just create more. This is number two. It's called foobar. It's called three. I'm gonna call this fish bus.
Oh, that's interesting. So same endpoint.
Same endpoint, but I'm gonna
Mhm.
support instead of here. I'm gonna support three.
Sorry.
I'm gonna upstream. Uh, Void HTTP handler max1, max2, max3. Okay, I'm gonna do the logic here. I have to put in text. I need a value I integer. Okay, simple as that. So every time I'm gonna do a log a mutex log. For any question about mutex, probably we cover it next
Yeah.
week or something. So here, and I'm gonna implement I plus. So AI length a streams okay a upstream. Basically, I'm doing a modular of I'm doing a very naive round robin of a very naive round robin. So right, because every time I increment it, so it will become like to the next one.
Yeah, yeah. Interesting.
So stop. So now, okay, do a call again. Cuba, please pass. Hello.
Nice.
We have a very simple round robin load balancer.
Nice.
Just by you see, there's not much of a differences.
Yeah, yeah.
Code. Yeah. As long as you familiar with the tips and tricks are actually in getting familiar with the interfaces.
Nice.
Okay, it's as simple as that.
I need to see how to do this on Node.js.
So I think we probably need to wrap this up. This is a bit of like a preview or like a experiment before we do it more often. But,
Yeah, yeah.
any question from you, Anju or Tristan?
No questions from me. I think it's well, this particular way of using a muxer is interesting.
Interesting.
I haven't seen it like that, done like
Yeah,
this before, but I know it's possible, but not the way like this.
yeah. Same here. Interesting.
So anything we if you're gonna do it often, do you want to do it often? Like
Yeah, yeah. I think that will be a good idea. Yeah.
or what sort of stuff that you want to pick up? Because right now I'm just for starter, it's like I'm going to give you guys tasting plates, like so you can see what you can do first before we get
Yep.
into the basics. Because going directly to the basics might be a bit dry.
Mm-hmm. Hey, other question is, let's say now you wrap this method. Sorry, this file has a lot of functions. How do you modularize it?
Modularize it.
Yeah. So do you just like do you create one file for each function, or just keep
The
bunch of function in one
if you're
meaningful?
are you familiar with Java?
Yeah. Class.
Is Golang actually follows similar to Java's directory based package.
Oh, okay.
So your
Mhm.
I'm gonna create let's say I call it lib.
Understood.
So I have
Mhm.
lib.go. They
Then
have
lib,
share the
lib.
same namespace. They're gonna
Yeah, okay.
yeah. So here lib
Uh,
will be instead of like Python is like file based kind of
yep.
package, right? But
Correct. Yeah.
Golang is actually let's say x.go is they share the same package under the same directory.
Mm,
And when you import this, let's say I have a func a here.
mhm, mhm.
If I'm gonna
So
import this,
outside would be lib.fun.
Yep. So it's actually that's why the directory structure is very important as well, because it's also it's the convenient part, but unfortunately it become a bit uh troublesome afterwards, that your package name is also, it's actually similar to Java,
Yep.
like your package name is also your reporting.
Yeah,
So because like familiar,
yeah, yeah.
let's say this is called familiar because I don't want to call it tutorial. If I kind of import lib, you're going to be lib here. But once you
Yeah.
imported here,
Mhm.
uh, the name of that package will be imported. So it's a capture as well. You
Mm.
want to be really nasty, you can call it like X. And when people, even though when people imported because the physical library is located at lib, right?
Yeah.
But when you import it, it's actually imported lib. So what
Mm.
they are looking for is actually XA instead of lib A.
Ah.
If you want to be really nasty, be careful about that. So
Interesting.
so there are cases where people might do that, and you want to. So some people that do this, you can actually reassign them.
Alias set.
Yeah.
Mm. Nice.
Yeah. And Golang doesn't like unused variable or import, but
Yeah, I just noticed that when I was trying playground. It just
method of getting used to.
it just throws an error.
And in my case, the dilemma is if I don't import it, I don't get the autocomplete. So sometimes, if you notice, I do these kind of things that complete the function,
Yeah.
let it import, then I gotta go back for the reference sometimes. It's
Nice.
up to your setup. It actually can be solved. I just don't want it to look up to global and waste so much of my CPU cycle for development.
Nice.
Yep. So I think that
Mm.
should conclude for the day.
Yeah. I'll
Just probably just put up any like requests or stuff you want to see what you can do and stuff. But the interface part and the I/O part is definitely the strongest part in Golang.
Mhm.
It's that also I still find it very fun to play to do things with I/O in Golang nowadays. That is until now, even like almost 4 years of using it exclusively.
Oh, because last time, basically it's like I read about, or let's say 500 MB JSON file from S3,
Yep.
so I had to use streams,
Yep.
and it's going to be long running. It's going to take time, so I was using Node.js streams for that. So yeah, it would be
Oh, we can
quite.
do that if you can come. If you want to, you can give me the big file and we do it probably next week. Like
Yeah, yeah. I think maybe let's
how we load a really big file into a memory and process them as
transform
fast
it.
as possible, or also as minimum footprint as possible.
Yeah, exactly. Yeah, maybe you can try that. Yeah.
Can we also do like parallelized
Yep.
Hmm.
reading with, for example, we divide it into 8 and
Yeah.
then you download all of them at the same time?
Yep.
Yes. Yeah, I
Okay.
think that would be a good
Yep.
exercise.
And
Yeah.
also that will definitely involve Go channel.
Oh,
Yep.
okay. That's
So
nice. Yeah,
Go
yeah.
channel is actually very straightforward, but we probably gonna cover try to do it every Wednesday if possible. Like want to keep it at 1 hour then. Because
Yeah, yeah, yeah.
this week is a bit rushed because the setup everything just messed up on me.
Yeah. Yeah, thanks for your time, actually. Yeah.
Hopefully it'll be useful for you guys.
Yeah.
Yeah,
Thanks, Chilyong.
Yeah, no problem.
yeah. First time I see the Go code.
Yeah. Oh really?
Yes, no.
You should have asked me, man. I'll kind of stop the podcast then.
No, but the example you showed is very interesting. I never even thought